Hi, I'm Eoin from Edge Impulse, and today we're going to be doing some on-device machine learning. We're going to build the model that I'm passing around. So anyone who's come to our booth, they'll have seen the visual anomaly detection demo, and that's running on device, and it's been running all day without draining the battery, and it's doing some ML on device. So you can use it for inspecting parts in a industrial automation scenario. And what we're going to do today is we're going to clone the example repo, the template that you can use to build your own model with Edge Impulse, and then deploy it to an Android device, like the one that you're seeing being passed around. That's a dev kit from Qualcomm, but you can also deploy to wearables like a Wear OS device, or even a XR AR headset like this, which is Android based. And to do that, normally you would have to know how to build and train your own model on TensorFlow and know how to interact with the operations yourself. But we abstract away all of that at Edge Impulse with our SDK and the template that you're going to see today. And all you need to do is pass an image to your Kotlin run inference function, and then you're going to get the results back. So if you can scan this QR code, or go to this link here if you don't want to scan the QR code, that's fine too. You just type in GitHub Edge Impulse example Android inference. So once you get to the repository here, I'm going to go here as well myself. So yeah, you're going to land to this repository, and I've added some notes here for the workshop today. So all you need to do is join Edge Impulse for a starter. So if you don't know what Edge Impulse is, hands up who saw my talk yesterday about what Edge Impulse is. Oh, great. So I had a few who came back. So I can really quickly show a slide just to show what Edge Impulse is, but I want to get hands-on and get everybody into Android Studio and get you to have this app that you see that we've demoed passing around functioning on either an emulator on your laptop or on an Android device if you have one with you. So let's go back to the slides really quick. So Edge Impulse is a platform for deploying ML models to any device. We can train them. I'm going to show you very quickly how we can train one. So the visual anomaly detection one that we had today, we can grab it from the test repository here. So I've got the binary you can just grab straight away, but I want to show you the project. It's not loading. Okay, yeah. So if we want to be able to train our own model to detect defects like cracks like this, we need to build our own data set. So we need to be able to capture many images and label them of concrete that's in a good condition. And then we're going to be able to run a model on the device that's able to see alert to anything that has been detected that sits outside of that data set, and it's triggered as an anomaly. And that score and positional information then you can use in your application. So we can build application logic that can then overlay some tracking here. So I know somebody had a use case of being able to inspect footwear defects. So fraudulent footwear, I think, was one of the use cases. So if you wanted to be able to highlight something that was anomalous in an image on your application, you could do that, and you have the positional information to highlight it here then as well. So that's what the end goal will be. So let's get into the code. So first we're going to clone the repository here. So and while that's downloading, you can also be signing up for Edge Impulse. Okay, so I should have that there now, and I'm going to open up Android Studio. And I'm going to kick off, open the project. So go into my downloads, and you'll see your example Android inferencing. And so we've got 3 templates that are included in this repository. The first one is the static buffer. This is like our hello world that you're going to pass a byte array to, and then you'll get your result of your inference. So when you create a project on Edge Impulse, you're going to have some features that you'll be able to access, and you can pass it in there. But today, what we're going to do is the camera inference example. So when you've downloaded the Git repo and you go into the camera inference, then just hit open, and you can trust the project, and that will start to populate then in Android Studio. So is everyone following along here for the project? Okay. So now you've got the Android example template. I can just show quickly the structure that we have here. So inside the app source main directory is the C++, and this is where your C++ binary will go, and the Edge Impulse SDK to be able to run inference on your device, and that runs on the TensorFlow library that you're going to download next. But once this is done populating, I think it's still building for me now. Once it's done populating and we've dumped in the binaries, one second, I just need to grab them again. Then you're going to come back here, and you're only going to work in the Kotlin area of this Kotlin. So I'm going to go back to my repository here, and instead of having to go through the training process right now at the start, we're going to just grab the export. I've uploaded them here. So export the C++ binary. So I've got it. I should have it here actually. Oh, here it is, the export. So we're going to grab this zip. Yeah, so I just want to get everybody to have this running on their laptops. So if you want to build an application around one of our models, you'll have the template on your laptop that you'll be able to do it. So after we're done populating this template on Android Studio, we'll then go into the Edge Impulse platform and walk through how you can build your own model. So, and you can use some sensor information like an accelerometer from your mobile to capture some movements like star jumps if you wanted to do an activity tracker, or fall detection if you wanted to build a care home application for a wearable or for your mobile phone, and also a keyword spotting example if you wanted to make some smart home device examples. So I've downloaded this zip, and I think the network, one second. If this isn't downloading for me quickly, I've already got it from earlier. So what I'm showing you now is the output of an Edge Impulse project, and what's bundled here is the C make list file for making our C++ project. We don't need to take that because the template has already been configured for the native development kit in Android. Typically, Edge Impulse projects are deployed to embedded hardware, but we're not going to do that today because Android kind of lowers the barrier to entry for people that may not have embedded development experience. And it's a much broader community as well. Android is the first device that many people touch as a child. Like as a child, everybody gets a Android tablet, but then you can scale up to extended reality headsets, wearables. Like it's just such a broad ecosystem. It's really cool to be able to start there. But once you start with Edge Impulse, and the whole point of doing machine learning on device is to learn about AI in a kind of a functional way. But if you start with Edge Impulse and you end up with the C++ binary, you can always move that to hardware in the future. So if you wanted to build like a wildlife tracker or a wearable, you could even port away from Android. Or if you wanted to build some factory automation, PLCs or things like that. Yeah, so I'm kind of jumping ahead here, but I'm just going to grab these distributables and I'm going to put it into the Android project. So I'm going to open that in your Finder and go into the app, source, main, C++, and you're going to see that, there's the C make list here already, so don't replace that. Just paste this in. And is everybody on Mac or is anybody on Windows? Is there anybody on Windows? If everyone is on Mac, that's fine, because we have two scripts because you need to download some of the TensorFlow-like binaries. One of the scripts is Bash format for Windows, and the other is SH for Mac and Linux. So we just need to go into the TensorFlow, the TF-Lite directory, then that's in the C++ directory, and run the script to download those binaries. Okay, the script is just going to download them and unzip them, and they'll be placed then. This is pretty much it to configure in the project then. It's going to start running at the demo that you've seen handed around, and after that then we're going to get into a project, and I'll show you just how you can kind of gather new data if you want to build your own example. And then afterwards, hopefully we'll be able to do some customization with Kotlin as well. So I'm kind of new to Kotlin myself, so interested to see how people build the UI themselves. Hands up who likes to use Compose? Cool. Yeah, I'm definitely loving it. Like so far, I'm like, that's good to see a few hands, because like XML just melts my brain. I don't know. the Compose just maybe if you're like more into the UX and UI, then you probably like the XML still and being able to craft that all yourself, but it just breaks my brain. Okay, so I've downloaded everything now. All you need to do now is make the project. You might need to clean it. Let's just see. I'm going to run a clean. So you go into build, make project. At this point, if you don't have the NDK, the native development kit for running C++ libraries, it's going to tell you that you need to install it. It doesn't take too long, about 2-3 minutes. So now if I hit play, I should get a emulator. Yeah, and Okay, it installed, but I didn't see a camera there. I'm going to try connecting it to a real device. Yay, okay, it works. Not sure what was going on with my emulator, but it's really that simple. I just wanted to get straight into the code and show you like the steps that it takes to configure it. At this point now, you're Kotlin developers already, so you should be able to just jump into the main activity template and start to build upon this example, and then you can incorporate it into your own applications. And this is an industrial automation example, but we've got other ones from our expert network for keyword spotting, so the likes of your Alexas and your, I don't want to say any more of the wake words in case there's any devices around me, but you can integrate this into your own applications. So you could use it for like accessibility, for voice control of things. If you've got privacy concerns, you can do some vision systems on your device here. Like, I don't know if anybody has security concerns about smart doorbells or smart speakers in their home, but I know I like to play around and make some just home automation things for myself, like controlling window blinds, things like that. But you make some really useful stuff as well. Like if you look at Wear OS devices, you can analyze the signal from a PPG or an accelerometer to build very complex sleep pattern analysis systems. You can do the similar on Android devices as well, and yeah, it's really limitless. Is anybody using AI on device at the moment in products or for some of their own systems? Or is anybody using a cloud service with AI? Yep, guilty. No, yeah. So like, hardware is really getting to a point now where we can do this usably. Like I'm using a current generation here, but my demo that I passed around also runs on like almost 10-year-old Pixel 3a, and it runs very usably. The device doesn't heat up. Hands up, has anyone ever used OpenCV on an Android device? Because like that really kills the battery, and you can feel it heating up. Yeah. So like, I don't have any like figures to compare it to, but I would be really interested in seeing like how a similar vision-based model on OpenCV compares to using it like this. I mean, you can see how fast this is in real time. Okay, so that's pretty much it. And actually, the thing has been running all day as well. So I don't have any real figures, but it's amazing how efficient these things run. So that's the template that's configured. Let's do a real quick walkthrough of how you build a project on Edge Impulse. Now that you know how to use it in your Kotlin. So I'm going to start with a completely new project here, and I'm going to start on the personal tier. I'm going to create a public one. And who's interested in a keyword spotting example or like accelerometer based example? Is there a keyword? Like keyword is like our hello world of starter projects. So when you create a project with Edge Impulse, when you sign up for Edge Impulse, you get 2 free projects on private, and the rest are public. We have a very generous developer tier. So we're connected to Harvard University, and there's many universities in the States that are teaching AI using our platform. And we have very generous developer tier. So you can use us really in proof of concept, and you can use us right up to the point of where you're going to start making money. And then you can speak to our sales team. The licensing fee is pretty reasonable as well. But if you want to use this in industry, then as well, that's a separate enterprise license scenario. But yeah, it's very competitive free tier. So I'm going to start with the droidcon example here. So I didn't get a show of hands for the type of data, so I'm going to pick accelerometer. I'm going to do an up-down movement to try and classify burpees. I'm not going to do any exercise up here, but do some like arm waving to simulate an exercise. Okay, so AI, your project starts with data. So a data set, we need to get the data onto your, we need to build a data set. So how are we going to do that? Well, there's many ways to do it on Edge Impulse. You can do it through APIs. If you can install us into a notebook, you can upload some CSVs. So the easiest way to do it is with your Android device, actually using the web client. So collect new data. I'm going to click on this. So straight away, you're going to get hit with a QR code that you can just scan. And you can scan this if you want as well. Like anybody, it's very good for collaboration as well. We can all kind of work on the same project together. So if you've got teammates in remote locations, they can all just have access to a project. And I've scanned it there, and it's just starting to connect. I can see my phone has been connected, and if I go back to the devices here, I should have a unique identifier, so I could call that Eoin's phone. Oh, okay, yeah, I have it there. And you can see what kind of sensors are available then. So I'm going to go back to my data acquisition and add new data. So I can see that I've got my phone connected, and I can pick what sensor. So from the phone, I could start to gather keywords. I'm going to use the microphone, but I'm going to use the accelerometer here to do some up-down movements. And maybe I'll use like a star jumps, I'll call it. So that's some labeled data, and I can pick how long I want the sample to be. So if it was like a 5-second sample, it depends on how long is the movement, like what input are you trying to capture and predict. So a star jump, maybe it takes about 5 seconds to do 2 of them. I don't know. Let's see. So I'm going to start capturing this. Okay, so I've got some movements coming in here. So the accelerometer has got 3 axes here. It's got the X, Y, and Z. And I can see that there's some movement happening in each of these axes. Okay, so that's great. And maybe I'll create another class called up, down. And I'll just do this. Okay, so I can see that there's up-down movements that are happening in the Z-axis. So now I've got 2 pieces, 2 data points gathered, and it's labeled, but I'm getting a warning here saying that my test train split isn't optimal. It should be 20/80. So you need to reserve a portion of data to be able to test your model against to see if it will perform as good as we say it does in the real world. So after you've collected about 6 minutes of data, you can save it, and then you get onto the ML architecture configuration part. So we've got, this is a kind of a very friendly view of the UI, and it's kind of an intuitive walkthrough. So when I click on processing block, this is a digital signal processing. So we've got some of our own algorithms here for extracting features that we need to pass on to the neural network to be able to detect the signal. And the way that you can process these signals, we're going to give you a star next to the recommendation depending on what the data is. So here we can see spectral analysis is great for analyzing repetitive motion, such as data from accelerometers, extracts features like frequency and power characteristics, and it's going to pass that on to the neural network then. So yeah, or I could use HRV if it was a PPG and you wanted to build like a wearable, like a ring or a watch that detects sleep patterns and heart arrhythmias. So, okay, we're going to go with the spectral analysis block. You just hit add, and then we need a learn block. So what we want to do today is classification. We want to be able to tell what type of activity is happening. Is it a star jump, or is it a up down like a burpee, or is the person in a rowing machine or something like that? So you can add as many classes as you want here. So it's classification that we want to do. There's no star next to this because we could do a number of other things as well. We could do regression, where we're trying to, this is like if you wanted to predict motor is about to start to fail, you could have some drift in numeric values. It's that's another common way to use it. So I'm going to add classification. So I can see then that the output features will be star jumps and up down class, and I could also add something else here like anomaly detection. So is something kind of like one of the classes but a little bit outside of it. You might want to trigger an anomaly for that situation. Yeah, so just go with the classification to start with. So hit save, and now if you have enough data that's been gathered, I think I've got about 10 seconds, so it's not a very good data set. I'm going to save the parameters, and this is all of these hyperparameters are pre-configured in a default way, but we also have an auto ML step that will go through and tweak all of the hyperparameters for you and give you a range of optimizations that you could use. So you might want to, I know that people are very concerned about megabytes when it comes to deploying to the App Store, right? So you want to keep the size of your app down. That's kind of a main concern on Android, of what I understand, but on the embedded side, you might have like latency concerns. So if you've got a motor that you're trying to predict on, does that screen keep flashing? Sorry. So yeah, you might want to optimize your model for different use cases. It could be RAM optimization, could be ROM optimization, could be latency, could be size of the model. Something's happening there. Sorry. So yeah, once that's complete and you've extracted your features from your digital signal processing block, you can move on to the neural network configuration. So hands up who's done some Keras before, or has anyone trained an AI model before? So that's great, because you don't have to have any prior knowledge, but if you did have prior knowledge, you would be able to get in here and configure the block, the neural network layers. You can write your own Keras. You could work with us in a notebook at this point. This is where you can collaborate with your ML engineer. So I saved those parameters, and I can see how long it's going to take to process and how long the classification will take. So this is how long it will take to do the run inference when you're in Kotlin, how long it will take you to get the result from that byte array that you've passed in. And this is all of the training is happening on the cloud in our infrastructure. We're based on, so this is like a Kubernetes cluster in the back end that's training our model, and the output then we're going to see the scores. So we'll see how accurate it is. I'm not expecting much from about 2 seconds of data, but I just want to quickly go through the workflow here. You can get a model trained in about 10 minutes, so it's crazy. Once you get to the endpoint, then you've got your C++ library. You can just dump it into the template that we built at the start of the session, and you've got your own model that you can integrate into an application and put it onto the store. And it could do wake words, it could do visual inspection, it could do predictive maintenance. Like, the scope is limitless here. Like, does anybody have ideas of how you might want to use this in an application? I'd be definitely interested to see what are people working on Android? Is there any visual inspection or healthcare applications? I can keep guessing. Maybe automotive? Oh. Okay, so I've got the results here. I can see that I've got my two classes, I've got my star jumps, and I've got my up down. So we can see that these are quite clustered and quite far apart. So actually this is really good. So we're we would be able to build a good model we would be able to build a model that would be able to successfully detect star jumps or up down. I forget what we call this. It could have been burpees or it could have been chin ups. So we're on our way to building an activity tracker application now with our, and it only takes 13 milliseconds. And if the size of the model is a concern, or the RAM usage on your mobile device, I'm not sure how much. I mean, mobile devices have a huge amount of RAM now. We optimize for edge devices. These are small things from Arduino, Unos. Hands up, who's ever heard of an Uno before? Yeah. So you could run some very basic anomaly detection. You could probably run this model on an Uno, right? Yeah. So like when you think about this, running on an Android phone that has 4 gigabytes plus of memory, it's like 2K. Like it's no brainer. It's why would you want to send this to the data to the cloud? So there's our model. Now we need to train our neural network now. So this is where we can get in and configure our keras. So anyone who's worked in Google Colab Notebook before is be familiar. So if you've got any ML experts, they can write their own blocks. So all of the blocks that you're seeing today for Edge Impulse are hosted on GitHub, and companies can write their own, or people can write their own, communities can write their own. We have a pretty wide community as well. We've got about 200,000 developers, and we've got 500,000 projects built so far. And we were recently acquired by Qualcomm as well, so we're not going away anytime soon. So we've got a really good tie-in with Arduino. We have a really good tie-in with Android-based hardware, like Snapdragon under the hood. That's Qualcomm. So I think it just seems like the perfect community to try and learn about and see how we can integrate with. And I'm just really curious to see how you think that you could use us in applications. So hopefully that model has finished training. Model is complete. So why am I not seeing the results? I should be seeing the results. Switch back to simple mode, please. Okay, so I can see how accurate my model is now. So I got 42% accuracy, and that's terrible. That's really bad. You want to get around 70% here. But yeah, it's 10 seconds of data, what I was expecting. At least you can see what's going wrong and where you need to improve now. So let's see how so we didn't really reserve any test data to test on, but that's what would happen here. We would be testing against the test data and you get the results. And you're seeing it takes 1 millisecond to get your run inference. So however long it takes to run your function plus 1 millisecond, then you're going to get your classification result. You're going to get your star jump and you can build it into your application. So that's the model trained. Now we need to get to the deployment. So this is interesting actually. So for deployment, you can write your own deployment blocks as well. So if you wanted to write your own custom deployment block to package us as an APK, or if you wanted to write a Git action to package us as an APK, you could totally do that. You can integrate us, like we're an ML ops platform. So we can be fully integrated to your CI/CD. Is everybody using CI/CD for their APK construction, right? Yeah. So we're fully integratable through APIs, webhooks. You can get us anywhere. And we've got a Rust SDK. We've got Python SDK. You can run us anywhere. So what we're going to do to get our C++ library, it's very important here that you disable the Eoin compiler. The Eoin compiler is what we use for hardware optimization, but we want to get the TF-Lite model as an output. I'm going to click unoptimized, and I'm going to build. So the output now is going to be the C++ zip that we saw earlier that we integrated into the visual inspection application. But this one is accelerometer based. So instead of using the dot camera sensor, you're going to use the dot accelerometer. But you could use it. So in Android, it's just so easy to switch the sensors. It's unbelievable when compared to embedded. So typically we have to write drivers to access all of these sensors. But with Android, it's just like dot accelerometer, and you've got sensor information that you can feed into a model. So yeah, this is packaging up my zip now for deployment. And I've got C++. So droidcon zip, jump in here again, just ignore the CMake list because we're not going to deploy to hardware. Grab these, and what I'm going to do now is I'm going to go to Android Studio. So that was the camera one that we looked at. I'm going to switch over to the Wear OS one. So Wear OS is the sensor-based example that we have in the template. Is it switched? Hands up who's made a Wear OS app before. Has any? Oh, okay, cool. Yeah, there's not a huge amount of Wear OS. I was surprised at the event so far, but yeah, I'm probably biased, like coming from the wearables that Wear OS seemed like a no-brainer. But yeah, it's this accelerometer-based example we can put into Wear OS, and Wear OS is really cool as well because you've got in the templates that we have, you've got a presentation layer, which is your full app on your Wear OS. And then you've got a thing called I'm going to get this wrong now, but it's a complication. It's like the dials that you'll have on your chronograph watch. And those complications show numbers. So those numbers could be like the counts of your burpees. They could be the counts of your patient's falls. If you just want, like say you just wanted to be able to track something, you could just increment that counter on the complication. Or you could show some stress indicators from your heart. Yeah, it's really cool. It's like a sub app within it's cool. I've used that in the template. So the template has a presentation layer, it's a complication layer, so you can run your inference in the presentation, which is the full app, and then you can pass the result to the complication, and that's in the template, which doesn't want to open for me now. But is everybody running this on their own Macs right now, or does anybody want any help with getting set up? Or do you want to see any other projects? Okay, well that was pretty much it for what I wanted to show, but I'm going to go into the interface generated by the C++ library. Good point, I'll show you that now, thank you. So yeah, I'm going to show you the interface. I'm going to show you the run inference interface again. Just kind of recap of where we were, but I'll show it to you in the code. I'm going to show it to you in the example for the wearables. So file open here again, and instead of the camera one, I'm going to go to my downloads, droidcon, nope. Example Android inferencing. So we've got the static buffer one here, which we can grab you can grab some of your sample features from one of your examples, and you can pass it into that as a quick test. But what we want to see is the Kotlin one. So this is my example motion Wear OS. So I'm going to hit open, trust the project. So I want to show you the entry point here for the Kotlin. So here's what I mentioned earlier about the complication in the presentation. So we've got a main activity in our presentation, which is the kind of main app in your Wear OS. And I've commented out the various sensors that would work with our projects here, just to show as an example. So I've got your The first one that we use is the accelerometer. That's what I've used in the warehouse motion example. So here we are. So we've got a listener. We're going to grab some sensor information. We're going to store that into the buffer. So this is, we're going to output that we're collecting the data while it's building the buffer. And then on create, so this is the accelerometer. We could change that to any number of different sensors, like the gyroscope and heart rate one. At this point then, let me just find the entry point. Yeah, run inference. So this is what you want to focus on if you want to build your application. The run inference is what we're going to pass the buffer to from the sensor. So that could be your image that you want to send for classification, or that could be your 3-axis accelerometer. So that'd be a three-dimensional array that you're going to pass in. And then the result that you get will be the inference results. And that could include positional information as well if you wanted to do some object tracking. So if you wanted to be able to track the motion of a car on a screen, for example, or if you want to do some body tracking, different types of, trying to think of like different types of accessibility user interfaces. Could be vision-based, could be sound-based, could be, there was a very, does anyone remember the Moto one where you could shake to activate your camera? So you could build something like that as well. So that's it really. That's the only part that you need to get into. So the run inference, if I click on that, you can see that it goes down to my, so under the hood, we need to take a look as well. It's not showing it for me in here, but I'm going to open it in the Finder.
Okay, cool. Apologies for being late, folks. I was actually
Source main, so we can see inside here.
over there, not the buffer stage 3 that I was looking at here. Fortunately, I talked really fast, and I'm aware of that speaker. Fortunately, I talked really fast, so
Yeah.
we'll be able to get through this in time. Okay.
So yeah, this is your C++ class that if you wanted to change certain, so really like once you've got to the point of being able to run your inference and get the results, you're pretty much there to get started with an application. But if you want to do some complicated changes, or if you want to include some novel DSP algorithms, that's where you get into the C++. You might have to turn on some flags in the CMake list for different blocks that you want to enable, or different parameters. But out of the box, it's set up for classification and visual anomaly detection, and you really don't need to get into C++ unless you want to. And if you do, then you can grab me on the forum. I'll get one of our embedded developers to help answer the questions. If you have any questions on how to customize this or extend it further, or get access to the, if you wanted to do some hardware optimization as you move to one of the native devices, like an embedded device, we can help you out with that as well. So that's pretty much it. I'm going to go back to the start here. Edge Impulse Studio. So if you want to join us, if you want to sign up for edgeimpulse.com, the first place that you're going to hit is a tutorial. It's going to give you a tutorial on how to do a keyword spotting example. We didn't do that today. We did the accelerometer and the vision-based examples. The keyword spotting one it's a fun one to do. If you want to do your own, like, hey Alexa example, you want to do, like, everybody can connect to that. And I think that's probably like the easiest one that you could use in an application if you wanted to add some voice control. So did everybody sign up for Edge Impulse already? That's okay. You can do it later. But if you want to ask me any questions, come up afterwards. I think pretty much done now. I hope it was helpful. And we kind of got there in the end. The C++, got the library built. put it into a project, got the template working, gathered some data, trained a model. It was a terrible model, but like when you add more than 2 seconds of data to 8 minutes, then you're going to start getting a good one. Like, if you ever trained and worked with a company to try and get an AI model into production, building a data set is the expensive part. $10,000. You're going to be building like huge data sets. There's going to be cleaning of it, but to get something functional to test for POC, 8 minutes data is perfect. So thanks so much today for attending, and I hope it was helpful.